These are your notes on solving radical and rational exponent equations. We're also going to touch on some real-world equations not found in the textbook, but for the most part, our examples are coming from Glencoe 5.8. All right, so let's take a look at our very first example. The whole purpose and when we solve an equation is to isolate our variable. When we're dealing with a radical equation, though, we first need to isolate our radical expression. So looking at example 1, we're first going to subtract 2 from both sides of our equation, leaving us with the square root of x plus 1 equals 2. So now I need to deal with the radical. Now this is a square root, and to get rid of a square root, I'm going to square both sides of my equation, giving me x plus 1 equals 4. Now the last thing I need to do is subtract 1 from both sides, giving me a solution of x equals 3. Now the difficult thing we need to do and remember always when solving equations, we actually need to plug them back in to see if they're true, to see if they make my mathematical statement true. So when we plug 3 back in, we get the square root of 4 plus 2 equals 4. Well, square root of 4 is 2, and 2 plus 2 does equal 4, so it is indeed a true solution to our equation. Let's take a look at example 2. In example 2, notice that I have radicals on both sides of my equation. In this scenario, it's actually helpful to have 1 on both sides instead of 1 on each, or both of them on the same side, because what I actually have to do now is I need to square both sides. Now when I square my right-hand side, I need to remember that this means I actually need to FOIL this side out, okay? Remember, a property of exponents is the fact that I actually cannot just take away, or I can't distribute exponents, okay, into a binomial. But on the left-hand side, that just leaves me with x minus 15, okay? So on the right-hand side, let's FOIL it out. 3 times 3 is 9. We're going to have 3 times negative radical x. We're going to have negative radical x times 3. And we're going to have negative radical x times negative radical x, giving me positive x. Okay? So now we're going to combine some like terms here. And I'm actually going to try to get these guys all by themselves, because once again, I would like for my radicals to be all alone here. Okay? So let's bring the 9 over by subtracting, and let's bring the x over here by subtracting. So they come onto the left-hand side. X minus x will cancel out. Negative 15 minus 9 gets me negative 24. Then over here we have negative 3 radical x minus 3 radical x, getting me negative 6 radical x. Okay? Now I'm going to divide both sides by negative 6. Negative 24 divided by negative 6 gets me positive 4. So positive 4 is equal to the square root of x. To get rid of my square root, I'm now going to square both sides, getting me 16 is equal to x. Now once again, we do need to plug this into our equation to make sure it works. So we have 16 minus 15 equals 3 minus the square root of 16. Well, the square root of 16 minus 15 gets me the square root of 1, which is equal to 1. On the right-hand side, the square root of 16 is equal to 4, and 3 minus 4 is equal to negative 1. Notice that 1 does not equal negative 1, so therefore it is not a solution. It's considered an extraneous solution. Alright, this next example is actually the last one I'm going to have you do in the textbook, and then I'm going to have us stray from the beaten path and do our own example. So here we have a rational exponent in our lives, but once again, we're not going to treat it any differently when solving an equation. I still want to isolate my variable. So to do that, I first need to add 2 onto both sides. If you haven't noticed, we're basically doing the reverse order of operations, okay? So now we have a 2. Next, we need to divide both sides by 3. And so now we have 5n minus 1 to the 1/3 power is equal to 2/3. Now, to get rid of this exponent of 1/3, the only thing I can do is raise it to another power. And the power that I'm going to raise it to is its reciprocal. The reciprocal of 1/3 is 3 over 1. So I want you to make a little mental note here. In any scenario of a rational exponent, always raise the power to its reciprocal. Okay? So in this case, we're just cubing both sides. So now we have 5n minus 1 is equal to 2/3 to the third power. Well, 2/3 to the third power is going to be 8 over 27. So now, I'm going to bring my steps over here. That way you can see them. I'm going to add 1 to both sides. And when I add 1, I'm really adding 27 over 27. Okay, that way I have a common denominator. So 5n is equal to 35 over 27. Now I'm just going to divide both sides by 5, and I'm going to get that n is equal to 7 over 27. Oops, 27, not 25, Miss Rudolph. All right, let's take a look at this real-world example that I've created for you, because that's the other part of this learning target. Solving equations when given a formula or given a real-world situation. So we have this problem. The strings of the guitars and pianos are under tension. The speed v of a wave on the string depends on the force or tension F on the string and the mass m per unit length L. According to the formula, v is equal to the square root of force times length over mass. A wave travels through a string with a mass of 0.2 kilograms at a speed of 9 meters per second, and it is stretched by a force of 19.6 newtons. We're told to find the length of the string. All right, so we need to plug in the information that we know. Some things that we know. We know that we have a speed given. Speed, remember, are going to be our v value. Okay, so 9 is equal to the square root of. So the force that was given, 19.6. Okay. We were not given our length, and that's what we're trying to find, and we're given a mass of 0.2. All right, so now we need to isolate the variable we're solving for. If we're solving for L, we first are going to need to get rid of this square root, so we're going to square both sides, getting us 81 is equal to 19.6 times length over 0.2. So now I'm going to multiply both sides by 0.2, because that'll get rid of my denominator. And 81 times 0.2 gets me 16.2 is equal to 19.6 times our length. Now I'm going to divide both sides by 19.6. And 16.2 divided by 19.6 gets me 0.82653. Okay? Now I want you to be super cautious. If I asked you to round, let's say I have you round to the nearest hundredth. Hundredths is our second decimal place. So rounded to the nearest hundredth, we would have 0.83.